Hey guys, we're starting with 4.1 power and heat. It's about an energy diagram and calculations with power and energy. Calculations with power and energy, there, yeah, we've done that before with electrical energy, and yeah, we need to see how it works with heat. So what's going on? Well, if you find it a bit difficult to see what's going on, a good first step is to sketch it. So what I have a kettle on a stove. So here I have my nice stove and there's a kettle on it. So something like that. So this is the kettle and it's on the stove. And we have a time and then we have heat. Hey, what is heat? Heat is that the water gets hotter, gets more warm. And so, yeah, it can do more, it can burn your tongue a bit more. So it's energy. So heat is a type of energy. And so we can calculate with heat and power and time. With electrical energy, we had that the electrical energy, was the power multiplied by the time. Instead of the E for energy, we can also use the Q for heat. Heat is a letter Q, so Q is the power multiplied by the time. And hey, now we know what Q is, we know what G is, you can calculate P. That's nice. Hey, you can do it yourself. Try it yourself. We'll discuss it at the beginning of the class. And the other thing I want to show you, instead of this drawing, we could use a different drawing, an energy diagram. How it works, we start with a rectangle, and that is whatever is transforming one type of energy into another. And that is in this case the stove. And then something goes into it, the arrow going in, and it's the energy going in. And what type of energy goes into the stove? It works on gas, that's an chemical energy because it burns. And when it burns, it's chemical, so it's chemical energy. And something goes out of it, and now what goes out of it is heat. It's another type. It's also energy, and these arrows should be the same height, have the same height, because energy is not created; it is simply transformed from one type into another. If you take a look at it, then we know this how the amount what it is. 355 kilojoules, and we know the time, 4 minutes. Try to calculate the power. Hey, see you then. Bye.